is by Abram. Okay. Are you able to share your slide?
Can you put me in the spotlight?
Oh, spotlight. Okay. There we go.
All right. And I want you to verify that this text is readable.
Yeah, I can. Yep. Analyzing the effect of.
All right, good.
Yep.
All right. Hi, I'm Abram Hindle from the University of Alberta. And today I'm going to talk about how my mining software repositories class deals with BOA. And I'm talking about specifically one paper that's pretty successful with it. And this is analyzing the effects of test-driven development in GitHub. This is published in ICSE, and we presented it at ICSE 2018 on the journal First Track. So the students, they really cared about test first because test first is prescribed by agile software development, especially extreme programming. And everyone is guilted over the fact that they don't engage in test first. The idea with test first is that you write your test first, then you write the code such that it enables the test to actually pass, and you refactor your code such that it actually passes the test. You refactor your code, you can update the test ahead of time, run the test, see the failure, and then update your code. So it's this recursive kind of cycle of writing tests and then writing code to pass and meet those tests. But it's typically used by agile consultants to guilt people into engaging in this form of testing. So a lot of people view it as a very important practice, but we really wanted to know, do people actually do TDD? And so there's a lot of consultant blogs and stuff like this where people are like, oh, you should do test first. Oh, you don't need to do test first. Oh, you're doing it wrong. You know, they want to sell consulting time. That's understandable. But at the same time, was it really value of doing it? And were people actually doing TDD? Furthermore, when people engage in TDD, are they capable of continuing to do TDD, or is it too hard? When I give this TDD exercise in class, where I ask the student to make tests for HTTP GET API, they usually go beet red, and they have a lot of difficulty with writing tests before actually writing the code. It's a difficult task for them. It takes practice. They don't enjoy that feeling, and so they don't necessarily carry on with TDD. So we wanted to look at TDD in the wild. Now, Fucci et al. Had studied TDD in the lab, and their stuff is really great. They were basically showing that the quality of test first and tested code did not really differ in the lab. So we wanted to see if that was the same case on GitHub. And this is where BOA came in. The first step was to use BOA to find projects that had testing. So we looked for Java projects that imported JUnit tests and Android tests. So that's pretty handy because you could just walk the AST, look for import statements, and you get actual import statements. You wouldn't get other random stuff if you were just grepping. So that was great. We used that, and I can actually show the the nice thing about BOA is the result is right there. So public job 30,188, and there's the source code, and there's the output. Bada bing, right there. So it's kind of nice that I can just go back to it. But that wasn't the only thing we used BOA for. It turned out that the students spent a good amount of time writing class coverage code in BOA. So they basically walk the tree and they make sure that that the test cases covered a certain amount of methods in the actual source code. So if it was X test case, they would check class X and see how many methods of class X were called by X test case. So that was the assumption they made. And BOA enabled this, which was really quite handy. Eventually, what was found out as out of about 250,000 Java projects, only 40K, 16% had test files. That's kind of sad. And then about 1% at most strictly practiced TDD. So that was kind of weird. So what we did is we're like, well, maybe we're being too strict on TDD. Maybe we need like a way to figure out if something is really TDD or kind of TDD or just a little bit TDD. So we made these test first and coverage knobs that allowed us to say whether or not tests occurred at the same time or within, apologies, the same window as the source code commits, as well as what test coverage was, which gave us basically a 2D space of projects. Basically how test first they were, so how tight were test code to source code changes, and how much coverage did they have. And this is a heat map of that 2D space, and we can see that there are a couple projects where they had 90% coverage and they're in a 0 kind of time zone. There were a lot more with weeks. The hot parts were actually not a lot of testing and not a lot of coverage. So low coverage was pretty hot. This 90% zone was pretty rare. So green is rare, white is not rare. So most TDD projects are kind of 50-50. Not everything is covered. And you get more TDD projects, the more looser you get with time. So with leniency of 1 day, minimum 50% code coverage, we had about 8,000 projects on BOA at the time that are TDD-like. So then we just wanted to see if testing versus TDD was any different. So we engaged in stratified sampling. We made clusters that were similar based upon their number of authors, commits, logical lines, and we eventually came up with k equals 10 to be a good point. So we wanted to ask, do they have more test files? Do they have more code? Do they have more commits? Do they have more authors? And we compared them against the control, which is tested codes. We are comparing TDD versus tested code. So light gray is TDD has more than control. Black is control has more than TDD. And medium gray is they're pretty equivalent. So did our control and TDD sets differ in terms of number of tests? Yeah. TDD had more tests. Did they differ in terms of logical lines of code? No, they didn't. Did our control and TDD differ in number of commits? No. Did they differ in number of authors? No, but that's also because we engaged in stratified sampling. So RQ1, did the adoption of TDD improve commit velocity? No, it didn't. Not until you loosened up TDD to be a weak window. Does TDD lead to more or less average commit velocity? No. RQ2, does the adoption of TDD reduce the number of bug fixing commits? No, it didn't. RQ3, does the adoption of TDD affect the number of issues reported for the project? No. So what was coming out is basically TDD and testing, like test after, was basically indistinguishable in the wild. Then we looked at, is continuous integration more popular with TDD? And does the adoption of TDD affect the developer collaboration? Well, the answer was no. Travis CI use was not different between TDD and not TDD. And in terms of adoption, it's not clear that there was a real difference between TDD and not TDD for accepting pull requests. So pull request behavior didn't really change. There was a little bit of skew, but it was really neat because BOA actually managed to get us there. And the students did almost all of it in BOA, which is different than what my other students did. What my other students did is they mostly engaged in using BOA to find project candidates. So they'd go and do a query on BOA to find projects. They'd export that, and they'd go to GitHub and download the projects themselves. Whereas these students were actually capable of engaging in BOA the entire time, which was pretty neat. But they did have to extract a lot of information from BOA to do statistical testing, which could be an improvement added to BOA would be a statistical test suite. So my suggestions based upon the experience of my students is that they really all needed easy extraction of information, CSV, JSON, XML, SQLite. if I go and look at some of their queries, many of these things were to generate CSV files, right? Many of these functions, escape lines, escape fields, format rows, it was just to make CSV files. So if they had, this was at the time, BOA could have changed. I'm only speaking from like 2017. If BOA had good exports, they wouldn't have needed that. It would also be nice if BOA had library support to allow the easy filtering of projects according to the perils of GitHub mining suggestions. That would have helped quite a lot. The AST walking was great, and AST walking is still a must, so it's a very important feature. But one thing that I saw students doing was exporting from BOA such that they could engage in AST diffing. So that was necessary. So be aware that there might be a need to actually engage in that. Coverage utilities would be great. The students wrote their own coverage stuff, but having coverage in BOA, like seeing, given one class, how much of another class is being covered, that would be nice. There was discussion by Robert about randomness. I really believe that for a lot of the stuff, we do actually need sampling, and sampling would enable the use of techniques like Bootstrap. We can't do everything all the time, and it's not feasible to do everything all the time, so sampling in BOA could be useful. And I really look forward to the integration of, say, software heritage or world of code graphs in BOA, rather than being project-driven, being a network of code. That would be really interesting. So if you're interested in any of the stuff, you can message me and I can share with you the actual data for the TDD project. It's about 5 gigs. That's my feedback on BOA. My students liked it, but in order for them to not use it just to query projects, there needs to be maybe a couple of changes. All right, thanks. I'll take questions.
Thank you. That was very, very helpful. That was very, especially the suggestions that you had at the end about the kinds of things that would have allowed BOA to your students to be more productive in this environment are definitely extremely helpful. I would make a request for, if we could have a copy of that text. We would very much appreciate that. And thank you again for coming and discussing this with us. So next we have